Hey guys, welcome back to day 63. Today we are going to continue talking about radicals, and we're going to learn how to rationalize the denominator. So rationalizing the denominator means we're going to eliminate any radical expression in the denominator, such as square roots and cube roots. So I'm going to show you how to eliminate it. So there's two examples here, but let me just show a different one, talk you through it. So say I had an example like maybe 7 over, let's see, radical 5. Okay, so say that was my final answer. Well, I want to make sure that I don't have a radical in the denominator. So what I'm going to do is multiply that fraction by 1. But the one that I'm going to multiply by is just going to be radical 5 over radical 5. Okay, so multiplying fractions, you just go straight across. When we do that, we get 7 radical 5. And what happens to the denominator then is, if I have radical 5 times radical 5, it would be radical 25, which is just 5. So that eliminates the radical symbol, okay? So that would be our final answer right there, okay? So notice our example number 1, we have 5 radical 2, 5 over radical 2. We just multiply that by radical 2 over radical 2. We go straight across, and we get 5 radical 2, and that's going to be over radical 4. We simplify that to be 5 radical 2 over 2. So this step right here I might eliminate and just say anytime I multiply radical 2 by radical 2, it's just going to be whatever's under the radicand. So if I look at 7 radical 3 over radical 3, I'm going to multiply by radical 3 over radical 3. So notice whatever that radical is, the 1 is just going to be radical 3 over radical 3. So we're really just multiplying by 1. Okay, but we take it out of the form, we take the radical out of the denominator this way. So again, we multiply straight across. 7 times radical 3 is 7 radical 3, and radical 3 times radical 3 is really radical 9 or 3. So we end up with our answer here. Okay, so we're just going to try some examples. All right, so first one, we're just going to multiply by radical 3 over radical 3. We go straight across, we get 2 radical 3 divided by 3. Okay, and we're always going to put it in simplest form. Okay, number 2, we notice we have radical 2, or square root of 2 in the denominator, so we're going to multiply by radical 2 over radical 2. So in this case, we get 4, and 3 times 2 is 6, so we have 4 radical 6, all divided by 2. Okay, we can simplify a little bit more here because 4 divided by 2 is 2, so we end up with 2 radical 6 as our final answer for number 2. Okay, so number 3, in the denominator, we have a radical x. So we're going to multiply by radical x over radical x. Works the same way with variables. When we go straight across, we end up with radical x divided by x, and that's our final answer. All right, number 4, in this case, we'll multiply by radical 5 over radical 5. We go straight across, and we've got radical 15 over 5. All right, number 5, we'll multiply by radical 3. Okay, we multiply straight across, and we get 2 radical 30 divided by 3. Okay. And 30 is in simplest radical form, so we're going to leave it like that. Okay, number 6, I'm running out of space, so number 6, I'm just going to do it down here. I've got 3x divided by radical x. I'm going to multiply by radical x over radical x. And when I do that, I get 3x radical x divided by x. I can then simplify it just a little bit more by canceling out the x's, and I end up with just 3 radical x as my answer for number 6. Okay, so let's move on. So that was simplifying. We're simplifying. Now we're going to go and we're going to talk about the quotient property of radicals. So last class we added, subtracted, and we multiplied. Now we're going to divide. Okay, so the square root of a quotient equals the quotient of the square roots of the numerator and the denominator. Well, what does that mean? Well, we have our two examples here, but let me just walk through one. So say I said, okay, what's the square root of maybe 100 over 144? All that means is I want to take the square root of the numerator divided by the square root of the denominator. And in this case, I would get 10 12ths. Okay. In the case of 10/12, that fraction can be simplified further to be 5/6. So that would be my answer. Okay, we have two examples here. One is 16/25, which simplifies to the square root of 16 over the square root of 25, so we have 4/5. And then we have the square root of 13 over 100. So in this example number 2, 13 is not a perfect square, so we end up with radical 13, or the square root of 13 over 10. Okay, 13 is in simplest radical form, so we're going to leave it like that. Okay, let's try some examples. All right, so the first one we end up with 36 and 49. Square root of 36 is 6. Square root of 49 is 7. There's our answer. Number 2, the square root of 3 over the square root of 100. We'd end up with the square root of 3 over 10. There's our answer. Okay, again, I kind of ran out of space, so number 3, let's do it here. We've got 25/8, so we're going to take the square root of 25 over the square root of 8, and we have 5 over radical 8. Okay, well, right now, radical 8 is not in simplest radical form, so let's put it in simplest radical form. We've got maybe 4 and 2, and 2 and 2. So notice 4 is the largest perfect square factor, so we can write that as 5 over 2 radical 2. But we want to get rid of the radical 2 in the denominator, so we're going to multiply by 1, which is radical 2 over radical 2. And we end up with 5 radical 2 divided by 2 times 2, or our final answer, 5 radical 2 over 4. Okay? So if at any point you want to pause the video and try one, you can do that. But moving on to number 4, we can have variables. Square root of x squared over the square root of 20. Square root of x squared is x. Okay, and then we have the square root of 20. Well, 20, again, we want to put in simplest radical form. So 20, let's do 2 and 10 and 2 and 5 here. So in simplest radical form now we've got x over 2 radical 5. Okay, we want to get rid of the radical 5 in the denominator, so we're going to multiply by radical 5 over radical 5 for our answer of x radical 5 over 2 times 5, because so it would be 2 times 5, and our final answer would be x radical 5 over 10. Okay, looking at number 5, square root of 16 over the square root of 4x to the third. Okay, the square root of 16 is 4. The square root of 4x to the third would be 2x radical x. Okay, so let's review how to do that. So the square root of 4 is 2. So that comes outside the radical. X to the third, if you remember, one group of x's with one left over. So that's how we got that. But in this example, we want to get rid of the radical in the denominator, so we're going to multiply by radical x over radical x. We get 4 radical x all over 2x times x. So our final answer would be, well, not final yet, but 4 radical x over 2x squared. And we can simplify once more because 4 divided by 2 is 2, so we end up with 2 radical x all over x squared as our final answer. All right, the last example we have, number 6, we're going to take the square root of x to the 6th power, okay, and the square root of 24y. Okay, when we do that, we get, the square root of x to the 6th power is just going to be x to the 3rd. And the square root of 24y, well, let's look at 24. We get 3 and 8, 4 and 2, 2 and 2. Okay, once we put it in that form, we can put it in simplest radical form. We've got 2 radical 6y. Okay, so we're going to multiply that by radical 6y over radical 6y. We go straight across, and we get x to the 3rd radical 6y divided by 2 times 6y. Okay, so our final answer, we're kind of running out of space here. Let me erase this. Okay, our final answer would be x to the 3rd radical 6y all over 12y. Okay, highly recommend doing the homework tonight and comparing your answers against the answer key that's posted on Student View. Goodbye.